So I'm going to try in 35 minutes to cover what accelerating modern analytics and governance is all about. In all seriousness, what are the business drivers for behind enabling the data management and analytics at scale? What are the governance models? What are the application reference patterns that we're seeing emerge? And then how Databricks fits this distributed data architecture. So before we jump into distributed data architecture, let's take a quick look at what we're seeing today in terms of enterprise data landscape. What I'm running into as we talk to our clients. It's typically a combination of what you're seeing on the right-hand side. They've either migrated their appliances to cloud, or they've migrated their legacy Hadoop clusters, or they built a new platforms through a series of use case-based activation. And on the right-hand side, you have operational data planes, i.e. all the systems that are generating data today. And if you think about cloud being the innovation engine in the enterprise today, application modernization strategy is typically predicated on decoupling, meaning moving from one application to using patterns like microservices to decouple the complexity in the application landscape today. So where you have today one data store, you will probably have 10, 15 in modern applications going forward. Add other data sources and data at edge. This journey from operational to analytical plane and automating decisions at scale, it's complicated, it's long, it's hard to govern, speed to insights are slow, next best actions are aspirational, and the bottom line, it's really expensive to manage these estates today, and it's difficult to scale. So how does the lakehouse reference architecture fits this model? We are seeing some of these with our clients, and yes, it does simplify some of the interactions that we see typically between these two different systems systems of insights, components of the systems of insights reference architecture, data lake, and read data stores at scale. It does simplify the pipelines. It does simplify the interactions between the different constituents in the enterprise. But our clients still need organizational scale, and they need organizational autonomy. So we're seeing this shift from data lakes, read data stores, supported by capabilities like Synapse and others, or Snowflake, to lakehouse reference architecture that addresses some of the data engineering and data management challenges that we're seeing with these legacy architectures. But the businesses, but the enterprises and IT organizations still need to enable the domain ownership, and they need to enable the decentralization of these estates organizationally. So our clients can move from lack of data ownership to domain data ownership. We're talking about data as a corporate asset, but in reality, the system of insights and machine learning models that the data scientists are building, they still lack quality. How do you enable data trust at scale? How do you apply policies and governance to data assets so you can move from IT enabled entitlement and management of provisioning access to data assets to data domain owners and data stewards provisioning or enabling the data use governance. It's difficult also to find and and interpret the data across the landscape. Yes, we are seeing Colibris, we're seeing Purview now emerge, but it's still, in most of the enterprises that I work with, as a business user, as a data scientist, as somebody who needs to quickly identify the data asset so I can build my next experiment, or I can bring the data sets together to support data innovation. It's hard to locate the data, and it's also equally difficult to interpret the data. So that shift from data estates where the data catalogs are not supporting this end-to-end data life cycle is part of the need that's business drivers, and part of the need that's really informing this next wave of data infrastructure modernization is how do you scale from single platforms, and how do you decouple these estates so you can enable more capacity. Central team today, if you think about it, most of the central ITs or the shared organizations in the enterprise, they're struggling for capacity. We've built these awesome systems in cloud. We're now applying Lakehouse reference architecture to address some of the challenges we've been talking about. But the central team, that capacity is, they're still struggling to really support the organizational needs at scale. If you think about the revenue-generating parts of the business, they're competing for capacity with other parts of the organization. So moving from a central team being the bottleneck to shared platform operations teams, there are being domain enablers is part of the rationale for this shift as well. There's a really, bottom line, it's the effort associated with integration and coordination of all of these pipelines and shortcomings and shadow IT is also part of the driver for really shifting towards a domain-driven design, development, and ownership. But at scale, if you think about it, it's really about applying microservices patterns to enterprise estates. And ultimately, it's about managing data as a product versus data as a byproduct. So how do we build the foundation for data at scale? How do we enable this decentralization and distribution of responsibility to domains? Those operational data planes will continue to exist. There are two really fundamental components of that building blocks to enable the decentralization of these estates. One is governance, and the other one is automated data operations. And I'll talk about it in a minute. And these two functions are enabling scaling of single platform to many platforms across the organizational landscape. Think functionally operations, shared IT. Think also finance, marketing, as organizations build this muscle of managing distributed data at scale, protecting the data at scale, and then enabling the automated data operations that are required to support these interactions. And great. So we need governance, and governance not only around can I identify the data asset that others are building, but can I also apply the data use governance? So I tried explaining is this IT managed model of identity access management that exists in most of the enterprises today. You go and request an access, somebody in IT goes and provisions that access for you, whether those are access control levels at the data lake or your RBAC model for the services or resources that you're using, etc. Shift from that model now as you're scaling and enabling the organizational autonomy and shifting really that data ownership from two domains and data stewards who are going to be managing their data assets as a corporate asset and enabling them really to take on this role of governance going forward? And meaning, can they provision data access for assets based on a request? Is there a mechanism to do that organization? And that's what this data governance capability supported by Purview for us is we are supporting Microsoft platform at scale really enables in terms of hybrid estate, ability to scan data sources both across on-premise and other clouds is what enables this decentralization of a state, both across cloud and a legacy or on-premise and other platform components. And the second component of this key capability is automated data analytics operations, meaning I'm able to identify, govern the data access, use at scale, but do I have the operations to enable the domain provisioning, data application provisioning, data source onboarding, to really move from this monolithic state to peer-to-peer interactions across the parts of the organization, and then within those organizations, are we providing the capabilities to data application teams to request both new platform components so they can build new products, or we are providing capabilities to business users so they can request data assets or onboard the data assets in production environment without significant IT involvement. How does this all come together? Well, if you think about what we started, we have governance, automation, you're hearing about data mesh. How, in terms of data management hub, federated computational governance that enables, that sets these rules of how we are going to work as a team, and what are the rules associated with what are the set of services that we're going to use organizationally, so that those data products that we're building within domains can talk to each other is a part of that function. Self-service infrastructure as a platform, also enabled from a data management hub standpoint. These are, in Azure, these are subscriptions and resource groups that are really responsible for governing, like metadata management, and activation of these data operation capabilities that I talked about, so you can both onboard new products, you can provision the platform components, you being a platform team and supporting these organizational nodes. In terms of building, so this is one dimension of scale. We have one platform, now we have 5 or 6 or 10, depending on the organizational landscape. So you're giving some autonomy. As a central team today, you're able to scale and provide the infrastructure to shadow IT that exists today in the enterprise so they can do their own thing. And you now applied some rules and governance model around how to do this with automation built in. Great. Now what's the next dimension of scale? Well, how do you decouple those analytic estates today so you can support both development concurrency, and you can move from horizontal team that today is managing data supply chain from ingestion through consumption at scale to vertical teams who are responsible for building these data products, and think a revenue generating part of the business today that's underserved by that central IT team. And tomorrow, now they have a shared infrastructure. You've created some, you enable the governance, We gave them a set of automated data operations capabilities so they can request services to be provisioned. They can onboard the data. Now, how do that revenue generating business, can they do more without central IT team being the bottleneck? Absolutely, yes. I mean, and that's part of this shift that we are seeing with our clients as well. Meaning, how do you think application modernization, where you have, or those of you who've been a little bit longer in this business, gang of four software patterns. Think microservices patterns like CQRS and event sourcing. Well, we are seeing the emergence of data product patterns as well. And these are not only software patterns in terms of how do we decouple these estates and what are the type of data operations interactions that these application teams will support. But this is a combination of patterns, infrastructure as code, application as code to really accelerate building of components within these distributed data estates. So if you think from left to right, today this is typical supply chain. You're ingesting data, you're applying some enrichment and curation, standardization, you're lifting the quality of data sets, you're creating business aggregates. Then you have some descriptive analytics in terms of read data stores, some semantic models that are going to support the interactive and retrospective insights at scale. Great. You have some predictive analytics, ML models. Today, this is a one pipeline. Complicated to manage. So yes, we've scaled the platform, but we still haven't really addressed the decoupling of separation of responsibilities, because you also have a different athletes. I mean, there are really three dimensions. One is patterns. Second dimension are the people. And third dimension is service mapping or services, tech mapping to these patterns. And what we're also seeing, this is, I believe, just the start of this journey. We'll start with the patterns to support modernization of the analytical estate. Functionally, this is going to map to products, customers, and then ultimately, it's going to also map to industries. So in manufacturing, we have a data application reference pattern for ingesting data in manufacturing. You know that there's a set of data sources that are common to that particular vertical. And then as you move to the right, what are the set of outcomes that we are enabling within that vertical as well? So those are going to be, I think, the building blocks and the evolution of the patterns as they exist today. So quickly, it's really there are 5 types that we are seeing today. These will evolve, but from the beginning, it's ingestion and curation. How do you get the data from sources? And how do you do this at scale? What is the acceleration that partners can bring to apply the agnostic data ingestion capabilities, metadata-driven? So you're getting the complexity out of this part of the engineering. And then in terms of discovery and onboarding, if you think about today, any enterprise, you may have sandboxes that IT has provided to data scientists. And they may have a way of onboarding data into that sandbox. But that sandbox is typically disconnected from your production data sets. Yes, in the data lake, in the lakehouse reference architecture, we are addressing some of those challenges, but you're still moving data around. You're requesting data. Who do you know? Send an email. Data gets onboarded somehow. The data innovation at scale, how do you enable that with governance models where you can request data and business or domain owners can approve that request, whether you're getting access in place, whether you're moving the data, or better yet, I'm a business analyst and I have my workspace in production. I have access to descriptive analytics, sales insights. I'm able to generate ad hoc insights for executives. And I have a sales, I don't know, some sales data set with market trends that I would like to mesh up with my production data set. Today, that drives a shadow IT organization, typically, where you have people doing their own thing in some sandbox somewhere or the environment that they built outside of IT. Tomorrow, you need to enable this capability organizationally at scale, in domains, so you can onboard data sets with governance, classification rules. Are you applying those as you go through this IT-assisted data onboarding process? And then from a descriptive analytics, again, how do you build these reliable and trusted data sets? Predictive analytics, wrangling, machine learning models, and then in terms of data exchange. I mean, if you think about that journey today, yes, in these single platforms and monolithic estates and some of the legacy reference architectures, yes, it's a pain to get the data all the way through, apply some machine learning models. Lakehouse reference architecture simplifies that. But you still have to provide that data to apply that intelligence across the enterprise value chains and enable this automated decision making. And if you're doing that as a single team that's managing this across, it's a lot more expensive and a lot more difficult than really separating the problem and dividing and conquering. And then using these patterns that ultimately build the data products that have interoperability expectations in terms of the services that are powering building of these products and how they're going to be talking to each other. So in terms of patterns to persona alignment, so one is the things that we do or build. Second dimension is who's going to be building this. And again, if you look at the organization, any IT and data community today, you have ingestion engineers, data engineers who are responsible for onboarding and curation. This is where a range of high code to low code capabilities, including Databricks. Discovery and onboarding today, a different set of athletes. Descriptive analytics, again, different set of athletes. It's, as I talk to our clients, and we, help, take them on this journey of, okay, we're going to modernize your reference architecture. We're going to add scale or introduce scale. And we're going to introduce also ability to start decoupling and scaling out. Who is doing this? Because there's a both technical aspect of change across these two dimensions, and there's organizational aspect of change. What are these vertical teams? How many ingestion and curation application teams do you need? Because today, let's say a team of 10, probably 5 or 6 people are responsible for core data supply chain engineering. And you have a fixed capacity. Think sprints, iterations. They only has 36 hours, last time I checked. So in order to do this at scale, how do you add team 2, team 3, so you can think, any merger, acquisition, or onboarding of new data sets? That's how you enable. Those are practical examples of where these patterns and personas and people and ultimately services come to life. So what we're doing is we're vertically carving out that supply chain and saying here, from ingestion and curation, here's a set of activities, patterns, infrastructure as code, application as code, that's going to accelerate building of data products. This is, underneath all of this is security and governance. As you build data assets, register them with a catalog. That event-driven metadata architectures are emerging in the enterprise. It's not, the fact that you've just scanned a bunch of data sources and have not really tracked any of the changes and the data that you're generating continuously and mapping it to catalog defeats the purpose of governance to begin with. From a discovery and onboarding, in terms of where Databricks and Synapse, for example, come together, is SQL-based analytics. We see with our clients Synapse serverless for SQL-like exploration, but with SQL-based analytics supported by Databricks as well. And again, organizationally, kind of if you think about it, one domain may use Databricks because let's say, I don't know, finance. You have a number of Spark, Python experienced engineers. And they're comfortable with using Databricks to support the engineering outcomes. In another part of the organization, they're a bunch of SQL developers. So you're not really tied to a single set of services. I mean, that federated computational governance model says these are the services we're going to support organizationally, and this is how they're going to talk to each other. Now, who uses what is really the function of change enablement and recognizing the organizational landscape and their preference to what technology they feel most comfortable with. Descriptive analytics, similarly. Synapse at the read data stores, for us at the center of enabling these retrospective and interactive insights with Power BI. And from a predictive analytics standpoint, it's ML flow with a machine learning to support the data science and machine learning outcomes at scale. And then from a data exchange, again, event-based models to support that automated decision-making, along with data sharing at scale through a service like DataShare or ADF. Lastly, from a teams and operations standpoint, platform, architecture, data management, one part of the change. Second part is teams and operations. So from left to right, where we have the platform teams today that with centralized architecture, with the competing business needs that they're serving, and a bunch of workarounds to really enable the agility, to platform teams that are managing those data management landing zones or platform operations, the core components of governance and automated data operations, to really enable this federated data ownership model, where you are scaling your platforms organizationally and then decoupling within those estates so you can support vertical scale. Common governance and management, improved quality and security, and then really increasing efficiency and access. What we're seeing is a new set of athletes really emerge. We were talking about data operations or automated data ops for a while. It's real. We're seeing platform operations teams with our clients. They're taking on building workflow, data governance workflows. How do you manage and curate a catalog from things like business glossary management to workflows that support data use governance, to building logic apps that enable some of the automated data operations. That's what that team is taking on. And they're also taking on support and the brokering between these different domains. I'm in one of these small bubbles on the right-hand side. I'm a part of the application team in a domain. I'm not going to take on DevOps. I'm not going to take on platform management. That's why this platform team exists. I'm going to request services to be provisioned for me. I'm going to request this data application pattern, which is a resource group with a bunch of resources and some automation that's specific for that specific use case. to be provisioned for me so that I can focus on delivering business value, building data products with the skills and services that are aligned to the organizational characteristics and the talent that they have. How does this look in terms of functional architecture and what we are seeing from bottom to top? This is a Microsoft a platform-aligned view, cloud adoption framework that governs the the networking and security fiber for modern cloud estates in Azure. You need deployment capabilities to start provisioning these platform building blocks that I've talked about. Management landing zone with the governance and operation. You need an agnostic ingestion, so you can support ingestion of data at scale and other platform build acceleration to support really accelerating or reducing the complexity associated with building data products. And then in terms of data plane, these are these data landing zones with data products or applications that are units of scale within domains. And then lastly, from an experience plane, we're seeing a lot of, we're seeing functional views and teams building custom UIs, etc. Our strategy is really to recognize, we're working closely with Microsoft teams at scale to really recognize what are the investments that for example, they're making in Azure Synapse, the next generation of Synapse, codename Trident, what it will enable in terms of the enterprise. So in terms of productivity experience, rather than building some productivity portals, leverage the Synapse workspace as that as the productivity plane for data analysts, engineers, scientists, etc. In terms of data cataloging, leverage the Purview as that unified experience for exploration and data governance at scale. In terms of marketplace, I think this space is emerging. You heard yesterday with Databricks catalog, they have a marketplace capability. Microsoft has building blocks with a next generation Cosmos Gremlin store to support some of these graph-based models that will recognize what are the assets that are being built organizationally, what is their value, etc. And then lastly, in terms of the activation, the automated data ops scenarios that I talked about, there's a set of them. And it's really, in terms of activation and how to get started, scenarios around can I request from a platform team, these interactions, platform deployment and provisioning interactions, and data onboarding. Those are the set of automated scenarios that we see emerge and that platform teams are taking on. But to wrap up in terms of how to get started, you have an existing estate with the workloads running in cloud. How to get moving? Think days, weeks versus weeks and months. Quickly activate, quickly align on what is the current state of capabilities, that scan of what are the services that I have, high-level design and prioritized use cases to really start activating the value. What's the MVP? MVP is not, think platform operations. How do you support this distributed state? How do you support data discovery? And how do you support data onboarding? That should be at the top of the list. Provision the platform, configure the catalog, first domain, ad hoc data onboarding, and the data products onboarded. Those are probably the right set of steps to get going. 0 seconds. Thank you.
Right on time. Thank you very much.